Buckle up, because today we're launching a deep dive into, well, the incredible journey of Voyager 2.
Oh, a journey is right.
I mean, just imagine this. A spacecraft launched way back in 1977.
1977.
Still out there, billions of miles away, exploring the cosmos.
It's hard to wrap your head around it.
It really is.
Oh.
That's Voyager 2, folks. And its story, well, it's a testament to human curiosity.
It really is.
Our drive to explore, to boldly go where no one has gone before, right?
Absolutely. And Voyager 2 has gone farther and longer than any other spacecraft.
It's the ultimate road trip. But before we get into Voyager 2's incredible discoveries, all those jaw-dropping images.
Oh, the images.
I think we need to grasp the sheer scale of this journey. Where is it right now?
Well, right now it's a relative term, you know.
Wait.
At these distances, it's mind-boggling. Voyager 2 is so incredibly far away that light, the fastest thing we know of, takes nearly 19 hours.
19 hours.
To travel from the spacecraft back to Earth.
Let me get this straight. If we could send Voyager 2 a text message.
Imagine that.
We'd be waiting almost a full day just to get that ping, that notification.
Yeah.
That's just wild. But how far are we actually talking? I mean, put that in kilometers for us Earthbound folks.
Okay, get this. At this very moment, Voyager 2 is about, get ready for this, 20.575 billion kilometers from Earth.
Okay, I need a calculator and a lie down.
That's like, traveling around the Earth over 500,000 times.
Okay, I'm starting to get a nosebleed just thinking about that. But it gets even crazier when you start considering that Voyager 2, it's not just sitting still. It's traveling at an average speed of 15.5 kilometers per second. Per second,
yeah.
That's, what is that, like 34,000 miles per hour? I mean, at that speed, Voyager 2 could get you from, let's say, New York to Los Angeles in less than 4 minutes.
Faster than a taxi ride.
Right. Talk about quick commute. But even that incredible speed, space is so unbelievably vast that it still takes Voyager 2 a year to travel roughly 3.3 times that distance between the Earth and the Sun.
Exactly. We measure those distances, those vast distances, in astronomical units. We call them AU.
Right. Gotta love a good acronym.
1 AU, it's the average distance between you and me. Well, I mean, between the Earth and the Sun.
I get it.
And right now, Voyager 2 is about 137 AU away.
So Voyager 2, it's out there, hurtling through space at absolutely mind-blowing speeds, covering these just incredible distances. But I have a feeling it's not just about racking up the miles, is it? I mean, this mission, it was about exploration, discovery from the very beginning.
Oh, absolutely. Voyager 2, it embarked on what we call a grand tour of the outer solar system.
I love the sound of that already.
Visiting Jupiter, Saturn, Uranus, and even Neptune.
Wow.
Each encounter a chance to rewrite the textbooks, on these planets.
A grand tour of the solar system. So let's rewind the clock a bit, back to 1977.
Back to the disco era.
Voyager 2 embarks on this epic journey. What were the mission's main goals? What were we hoping to learn by sending this spacecraft on its way?
Well, Voyager 2, and of course its twin, Voyager 1, they were designed to take advantage of this rare alignment.
Alignment?
A rare alignment of the outer planets. It's a celestial opportunity, really. Happens only once every 175 years.
Wow, so they had one shot at this.
One shot. This alignment, it allowed them to basically use the gravity of one planet to slingshot them onto the next.
Clever?
Which significantly reduced travel time. The main goal, to explore Jupiter and Saturn, of course, which were, still largely mysteries at the time.
So Voyager 2 was like a cosmic tourist with a really, really tight schedule.
That's one way to put it.
Hopping from one planetary wonder to the next.
Yeah, a cosmic tourist on a tight deadline. But the mission scientists, they were clever,
Oh, I bet.
They built in this possibility, of extending the mission.
Okay.
To Uranus and Neptune, if all went well.
If all went well, yeah. I'm guessing, based on where we are in this deep dive, that things went they went more than well during those first encounters.
To say the least.
So tell me about Voyager 2's first stop, Jupiter. King of the planets, right?
Oh, Jupiter was full of surprises, let me tell you. Voyager gave us, those first close-up views.
I bet.
Of the planet's swirling clouds, revealed the dynamics of its atmosphere. Just amazing. And we got to see the Great Red Spot.
Ah, the Great Red Spot.
In all its glory, confirming that it's this massive storm system, bigger than the entire Earth.
It's hard to imagine a storm that big.
It's bigger than our whole planet.
I remember seeing those images and I was just floored.
They were groundbreaking.
They were breathtaking, to say the least.
Oh, and there was another exciting discovery at Jupiter.
Okay, hit me.
Voyager 2, it found active volcanoes on Io.
On Io?
One of Jupiter's moons.
Wait, hold on. Volcanoes on a moon?
On a moon.
You're blowing my mind here. That seems like, I don't know, something straight out of Star Wars.
Right. It was huge. Before Voyager 2, we thought volcanoes were unique to planets.
Yeah, makes sense.
Finding them on a moon completely changed our understanding of how celestial bodies, how they form, how they evolve, the whole thing.
Amazing. I love how Voyager just keeps, turning our ideas upside down.
That's science.
So from volcanic moons at Jupiter, Voyager 2, it raced on to Saturn, right?
That's right.
The ringed planet. What wonders awaited there?
Oh, Saturn was something else. A feast for the eyes.
I bet.
With its intricate ring system really stealing the show. Voyager 2 captured stunning images of those rings, revealing intricate details never seen before, and even discovering new rings.
So Voyager wasn't just snapping pretty pictures, it was rewriting our understanding of Saturn's rings. Yeah. With every snapshot.
Exactly. More than just a photographer. And remember those new moons I mentioned?
Yeah.
Voyager 2 found several more at Saturn, tucked away within those rings.
Hidden gems.
It's like a cosmic hide and seek.
Amazing.
And you know what? It gave us clues about how those rings might have formed.
Okay.
In the first place, you see. Likely from the remnants of, shattered moons, other celestial debris, all caught, in Saturn's gravitational grip.
So it's like a cosmic recycling program.
In a way, yeah.
Old moons, they become these stunning rings. It's mind-boggling.
Nature's incredible.
Okay, so Voyager 2 has explored Jupiter, it's explored Saturn, sending back all this groundbreaking data, these jaw-dropping images along the way. But its journey, it wasn't over, was it? This is where we get to, like the bonus round of the tour?
Right.
Uranus and Neptune?
And what a bonus round it was. Remember, these planets, they were a bonus, not the original target.
Oh, really?
And no spacecraft, none had ever visited them before. So the anticipation for these encounters, it was sky high.
Yeah, I bet. The pressure was on. So in 1986, Voyager 2, it had its first date with Uranus.
Quite a date.
What did this icy giant have in store?
Well, Uranus decided to keep things interesting, that's for sure.
How so?
For starters, Voyager 2 discovered, get this, 10 new moons.
10.
10 new moons orbiting the planet, adding to its already kind of, impressive entourage.
More new moons. Voyager 2 really seemed to have a knack for finding those.
Yeah.
What else did it reveal about this mysterious ice giant?
Well, Voyager 2 made this surprising discovery
Right.
that Uranus, it's tilted.
Tilted.
On its side.
On its side.
With its axis of rotation almost pointing directly at the sun.
A planet tilted on its side. That's it's unusual, to say the least. Any ideas why Uranus looks like it's doing a cosmic handstand?
Yeah.
Best guess. Early in the solar system's history, a large object, maybe a protoplanet, collided with Uranus, knocking it, off its axis.
A cosmic hit and run. Poor Uranus. But hey, at least it's got its stunning rings.
Guys.
And those newly discovered moons to keep it company. Okay, so from the topsy-turvy world of Uranus, Voyager 2 had one final encounter, right? Neptune awaited. The final frontier for this journey, at least.
Right. And in 1989, Voyager 2 made its closest approach.
To Neptune.
To Neptune, sending back, you guessed it, the first close-up images of this distant blue giant.
Neptune, often called, the other blue planet. But unlike Earth, it's an ice giant. What did Voyager 2 reveal about this chilly world?
Well, we were surprised to discover that Neptune, it has this surprisingly dynamic atmosphere.
I know. With massive storms, similar to, to Jupiter's Great Red Spot. In fact, Voyager 2, it observed this massive storm system on Neptune. We called it the Great Dark Spot.
Another planet, another massive storm. It seems like these are more common than we once thought. Anything else? What about rings? Did Voyager 2 find any of those around Neptune?
It did.
No way.
We already knew that Neptune had this faint ring system, but Voyager 2's images, they showed us just how dynamic and clumpy they really are. The images, they revealed that Neptune's rings, they're made up of icy particles, shepherded by the gravitational pull of small moons.
It seems like Voyager 2 had saved some of its best for last.
It really did.
Those planetary encounters, truly remarkable. each flyby revealing new wonders, upending our previous assumptions about our solar system. Voyager 2's grand tour of the outer planets. I mean, it sounds like something out of a science fiction novel.
It's stranger than fiction.
Those close-up glimpses of Jupiter's Great Red Spot, discovering active volcanoes on a moon and revealing the tilted mysteries of Uranus. It's incredible to think that all of that, it happened decades ago, and this little spacecraft, the one that brought us those discoveries, it's still out there.
It really is a testament, to the engineers, the scientists who built Voyager 2.
They really built something special.
They did. They designed this spacecraft that's not only, stood the test of time, but it's continued to make these groundbreaking discoveries, even as it entered, this completely new realm of space.
You're talking about interstellar space, right?
Yes.
That vast cosmic ocean between the stars. And Voyager 2 crossed that boundary, the heliopause.
Yeah, heliopause.
Back in 2018, right. So it's not just, a planetary explorer anymore. It's an interstellar trailblazer. What's it like out there? What's Voyager 2 discovered since it left our sun's neighborhood?
Well, we're learning that interstellar space, it's not as empty as we once thought.
Oh, really? Tell me more.
It's filled with what we call the interstellar medium. It's this thin soup of gas, dust, cosmic rays.
Cosmic rays.
And Voyager 2, with its, it's still functioning instrument.
It's still going.
Still going. It's giving us our first real up-close look at this mysterious realm.
That's incredible. So you mentioned cosmic rays. Those are those high-energy particles.
Right.
That are just, I don't know, they zoom around space. I imagine they're a bit like microscopic bullets out there. Is Voyager 2 safe?
Yeah. It's a harsh environment.
I bet.
But Voyager 2, it's built tough. And it's those cosmic rays that are actually helping us understand, the interstellar medium better.
Oh, how so?
Because Voyager 2 can actually measure them. And those measurements, they're telling us about the density, the composition of the interstellar medium, what it's made of.
So it's like Voyager 2 is sending us postcards from the edge of the map.
Exactly.
Telling us about the cosmic weather out there.
Exactly. Every bit of data it sends back, it's helping us piece together this picture, a clearer picture of what it's like, in the space between the stars. We're learning about the galactic magnetic fields, the density of interstellar gas, and even encountering things we never expected.
Like what? Give me an example.
Okay, so for example, Voyager 2 it detected these bursts of cosmic rays that seem to be coming from shockwaves.
Shockwaves, like sonic booms.
Like sonic booms, but on a cosmic scale.
Wow.
These shockwaves, they're likely caused by supernova explosions.
Okay.
The violent deaths of distant stars.
So we're learning about like the echoes of events that happened light years away.
Light years away.
All thanks to this little spacecraft launched like almost 50 years ago.
It's pretty amazing. But remember earlier how we were talking about Voyager 2 and how it's running out of power.
Right. That bittersweet reality.
It's true.
It's plutonium power source. It's slowly, decaying.
And as that power supply, it dwindles, NASA, they've had to make some tough decisions about how to keep Voyager 2 going for as long as possible. They've been turning off some instruments, prioritizing the ones that are still returning the most, the most valuable data about interstellar space.
So every bit of data that we get from Voyager 2 now it's precious.
That's a gift.
Like a little message in a bottle.
Exactly.
Tossed across the cosmos from an old friend whose journey is, it's coming to an end.
It is. But even in its twilight years, Voyager 2, it's still teaching us. It's expanding our understanding of the universe.
What a legacy. What a legacy. What does the future hold for this intrepid explorer?
Well, eventually Voyager 2, it will run out of power completely and we will lose contact. But even then, its journey won't really be over. You see, it will continue to drift silently through interstellar space, a testament to human ingenuity and our thirst for exploration.
A silent ambassador carrying a message from humanity. And who knows? Maybe, just maybe, someday, far in the future, someone or something out there will stumble upon this little spacecraft, a relic from a distant world, a testament to our own small step into the vast cosmic ocean. Thanks for joining us for this deep dive into the incredible journey of Voyager 2. It's a story that, I don't know, that fills me with this sense of wonder and reminds me that the spirit of exploration, it burns brightly within us all.